Thank you. Yeah. Good morning, everybody. Hope you had a restful night after the test of yesterday. I Let me know if you are there or if we should go ahead just like that. I was informed that you are supposed to be in class today because if by the way we've been going, we might be ending this section of lectures today. You remember that in our last class, we were almost through with hydrides, and I think we were on page 8. But I'm going to start from page 7 today. On page 7 today, I told you that for the hydrides, that is the elements of group 5, they form compounds with hydrogen. And it was clearly stated that the stability of such hydrides decreases down the group. This is because, Paul, how are you? I am not too sure most of your classmates are here, but this has to be taught, okay? But it's still apparent that if by chance the physical class would hold, you people can organize it. And if it is convenient for me, if it's a good time, or we can rearrange, I'll be taking you in something that looks like a summary of everything that we've done in this section. All right. Now, as you go down the group, the stability of the hydrides of group 4 element, group 5 elements decreases. This is because of the bond length between this element and hydrogen. The smaller the element, the shorter the bond. And the shorter the bond, the higher the stability. Akwesi, I know that you all prefer the physical class. I also share your sentiments, but what you're experiencing now is a directive given by the university that it has to be done by telepresence. But that notwithstanding, if it is organized, I am not supposed to be the one organizing it. If it is organized, definitely I'll make myself available. Now, it will say that antimony. Antimony is the second to the last element in that group. It is giving us a bond energy, of 255. This is because of the length of the bond between antimony and hydrogen. And you know that the longer the length, the lower the stability. That is why it is easier. The hydride of antimony will be easier to break than the hydride of nitrogen. So if you are looking at boiling points, you will see that the boiling point of ammonia is expected to be greater than that of stibine. You look at the highlighted pages, page 7. It is said here that the bond length between bismuth and hydrogen is not included because of the what? Relative instability. The instability is due to the bond length. That bond length, which is very long, indicates that it is going to be very weak. It is going to be very weak. They exhibit tetrahedral shape, but usually it is expected to be distorted. Why is it going to be? When you compare it with the alkanes, let's take CH4. You know that exhibits an sp3 hybridization too, but that one is a perfect sp3 hybridization. But when you look at the hydrides of members of this group, they are also going to form tetrahedral bonds, but it's definitely going to be distorted. You know that a position is occupied by what? Lone pairs of electrons. These lone pairs of electrons interacts with these bonds. You know that bonds are also made up of electrons. There's always a repulsion. So there's going to be a distortion. This distortion is brought about by the repulsive forces between the lone pairs of electrons and the electrons used in bond formation. Phosphine forms salts with HCl and hydrogen under an hydrous conditions, while other hydrides do not form coordinate compounds. Phosphine is known to form salts because phosphine is relatively small in size as compared to the other members of the group. But the other members of the group will not form coordinate bonds. They will not form coordinate bonds because of their large size. And as the size increases, the electronegativity does what? Decreases. Obviously, we know that ammonia is a weak base, isn't it? It's a weak base because it has lone pairs of electrons. I know they have taught you something about Lewis bases. Lewis bases are substances that have lone pairs of electrons that they are ready to give out. Now, compare this with phosphine. Phosphine is the hydride of phosphorus. It is said that it is a much weaker base than arsine. A much weaker base than arsine. When you go down the group, size increasing, size increases, and you'll see that because of the larger size, the lone pairs of electrons are easily taken up by hydrogen. Because of the larger size, they're easily taken. Normally, the ease of release of electrons decreases down the group. But when it comes to the hydride of these compounds, the interaction between them and hydrogen alters this principle. So as we go down the group, the bond formed, the ease of releasing the electrons increases. They are all strong reducing agents. That is not too far-fetched because they release their lone pairs of electrons. Presence of lone pairs electrons is actually a very good condition for their reducing property. I don't want to go into that because these are just something that you can easily read. Now, but you can see something here. It is said that antimony is used as a printing component of metals, and they help in producing sharp printing edges and clear images. But compounds, this is what I want you to take note of. Compounds of antimony are less toxic than those of what? Arsenic. Compounds of antimony are less toxic than those of arsenic. Can anybody imagine what is responsible for this? Because if you look at the group, what is happening there, you will see that antimony has a larger size than arsenic. But what has got the size got to do with the toxicity or the toxic ability of this element? I want you to think about it. Why should the antimony be less toxic than arsenic? Can you tell me that? Can you tell me? Now, this has to do with their compound formation, ability to form compounds, and their ability to form compounds in this group is associated with the presence of lone pairs of electrons. And you will see that as we are going down the group, we are not talking about the hydrides anymore. We are now talking about elements in the group. The ease of releasing the lone pairs of electrons to other compounds, it decreases down the group. This might sound a little bit confusing, but it's not confusing because we had already initially told you that nitrogen will release its electrons more freely as compared to antimony and bismuth. But when you are looking at bismuth, we don't talk too much about bismuth because of its extremely large size. And because antimony would release its electrons much at a slower rate as compared to that of arsenic, it is going to be less toxic. That means that toxicity does what? Decreases down the group. But as toxic as they are, both antimony and arsenic are the best cure for these diseases stated here. They bring these diseases under control. But that means that a calculated amount of this species must be used. If they are used in excess, they will lead to toxicity and eventual death of whoever is having that disease or whoever it is introduced into. Let's look at the halides. These are compounds formed with halogens. Elements in this group form binary halides with two stable oxidation states. And these oxidation states are what? Plus 3 and what? Plus 5. And these compounds are known as what? Trihalides and pentahalides. I don't think you should have problems with this, because we told you that the two most stable oxidation states for these compounds are the plus 3 and the plus 5. The plus 3 and the plus 5 oxidation state. If you are asked in an exam to give the oxidation state, don't make the mistake of writing 3 and 5. The charges must be there. The positive charges must be there. Take note of today's attendance code. The first one is 4QLLB. It is 4QLLB. 4Q, that is the first attendance code of today. All right. Since we know that they form trihalides and pentahalides, let us look at what the trihalides look like. The trihalides are represented by MX3, where the M represents the elements in this group. And the stability of these halides also vary as we go down the group. And they can be formed through a direct reaction between these elements and any form of halogen as given in the equation. Okay, they are usually volatile and easily hydrolyzed in water. They are usually volatile and easily hydrolyzed in water. NF3 is stable, but NCl3 is what? Explosive. You see, if you understand the principles, you don't have to cram all these things. Why would NF3 be stable? You know that the fluoride is the smallest halogen that we have. The small size of nitrogen will be able to accommodate it, but the small size of nitrogen will not be able to accommodate the larger size of the chlorine. Therefore, they will be forced together, and once they are forced together, any additional input can trigger this explosion. That means that for these halogens, their stability will do what? Decrease down the group. They said NBr3 and Ni are known in their unstable what? Ammoniates. They form compounds in the form of products of ammonia, but they are still very, very unstable. And that has to do with what? The infusion of these entities into their shells. Nitrogen forms series of halides, and you shouldn't be too surprised about that because of its ability to do what? To form p-pi bonds. PF3 is very reactive. PF3 is very reactive, and it is used as a precursor in the manufacture of some organic compounds. Precursor in the manufacture of organic compounds. As we go down the group, electronegativity increases. It decreases. Electronegativity decreases. And this decrease in electronegativity has a major role that it plays in compound formation. Okay? Let's quickly look at the pentahalides. The pentahalides are compounds formed with halogens in their plus 5 oxidation state. And all the members in this group will form pentahalides except for nitrogen. And this is because of the what? Inability to expand its octets. Because of that, it cannot, and you know it's a period 2 element, it cannot expand its octet into the d orbitals. But pentahalides are PF5, PCl3, PBr5, and so as stated here, are all known. They are all known, but you will see that the larger size of these elements are combining with the smaller sizes of the halogens. That's the reason why they can easily form compounds like this. Furthermore, you will see that all these other elements can also do what? Expand their octet. They can easily expand their octet. Okay. Pentahalides are more covalent than the trihalides. Pentahalides are more covalent than the trihalides. Covalency, ionic nature, is all due to the differences in the electronegativity of the element. This element, as you go down the group, their electronegative character decreases. But when you are talking about the covalency of this entity, you will see that the kind of halogen that comes in that combines with this element determines the kind of bond that is going to be formed between them. Let's look at their oxides. Let's look at their oxides. Oxides and oxides. Only nitrogen, because we have already told you that its small size and presence of lone pairs of electrons will make it form p pi p pi, which means that it will have the ability to form compounds in various oxidation states. It is important to take note of this. Why this one is different from that of carbon is that carbon exhibits its p pi p pi bond formation with only oxygen, while nitrogen has the ability to exhibit its p pi p pi with other kind of compounds. So you can have more compounds formed with nitrogen than you can have with carbon. But carbon is unique because it is highly organic in nature. Now, because of that, you can have various oxides of nitrogen. You can see them as they are stated here in the plus 1, 2, 3, 4, 5, and 6 oxidation states. Examples are given. Their common name are also given here. Okay, the bonding between nitrogen and oxygen is best described by the molecular orbital theory. Now, this bonding, um, in your subsequent classes, you are going to be taught molecular orbital theory. It is not actually meant for this level, but we need to mention it. The lower oxides of nitrogen are neutral, while the higher ones are what? Acidic in nature. For everything we say here, we often try as much as possible to make you realize that there is a reason for all these entities. Why would the lower oxide of nitrogen be neutral and the higher ones will be acidic in nature? What necessitates acidity? Ability to lose electrons. As the size increases, the lower oxides will be neutral. Now, and the higher ones. Now, when we're talking about the higher oxides, what do we mean? We're talking about oxides formed in the what? In the higher oxidation state. What happens to their size? Their sizes are smaller, and it means that they have lost all the electrons in their outermost shell. So, because of their ability, and you know that positive charges are related to what? To acidity. Now, for instance, N2O, NO are neutral, N2O3 and N2O are relatively what? Unstable, while NO2 is acidic in nature. Please, when you are reading this, give you a reason why N2O is relatively unstable. What is the oxidation state of nitrogen in N2O? What is the oxidation state of nitrogen? Relates it to the size and the ability to gain electrons. But you know that electrons will be lost for them to be able to react with negatively charged species. Okay, preparation of oxides of nitrogen. Okay, good morning. Yeah. But um, silent minerals, one, you have all this. Okay, you have all this. I've already passed them on to you before now. I was given them before each lecture. But the problem I'm having now is that I don't really understand why this is coming up. You have them already. But you know, like I told you, after my classes, I'm open to end the classes with you today. You can send your representative whatever you want me to do to make you understand things better. If I have to resend them, it's no problem. I will send them to your class reps and they'll be distributed. Okay? So you don't have any problem with that. But like I told you, I've offered to make myself available if we actually have to meet one-on-one. All of you might not be there. You don't have to be there. Okay? But it is just up to you. I know I was told that you've not seen your chemistry 101 results. And I think this is what is responsible for your attitude. I will not break that news to you, but the result wasn't too good. And the reason why it's not out is because they're trying to see how they can help you. You cannot take this kind of attitude into the second semester examinations. You can't take it into the second semester examinations because if care is not taken, hmm, quite a number of you will be leaving. And next year, a lot of people are waiting out there to replace those that must have been sent out. Please take note of that. You can get in touch with me at any time. Let us look at the preparation of the oxides of nitrogen. Nitrogen, one oxide, is unstable. Therefore, it cannot be produced directly by reacting with oxygen. Okay? It cannot be produced. I'm trying to read your comments because your comments will give me an inclination towards your understanding and whatever problems you're having. Note this, I'm not a fan of this kind of class because I cannot accommodate your questions, but there's nothing I can do. I am handicapped because this is what the university said we should do. Because nitrogen cannot react directly with oxygen, okay? That is the reason why its preparation is quite different. The preparation of this oxide is quite different from the others, okay? It can be prepared from the decomposition of ammonium nitrate at a temperature range of 170 to 240 to give us the first nitrogen oxide, and then with water. Nitrogen four oxide, which is red brown, is a red brownish gas, can be prepared in the laboratory by heating up lead nitrate. You would observe that none of these nitrogen oxides are prepared by direct relationship between nitrogen and oxygen. And this is what has actually saved the world. Remember, the nitrogen is the most abundant what? Abundant element. If it reacts directly with oxygen, we will not have plants anymore. We will not be in existence because there will be no food. There will be no food. That is why usually, even when nitrogen is introduced into the soil, it is introduced in the combined state. Note the commercial preparation. The preparation of NO2 is by the oxidation of NO, often experienced in the manufacture of HNO3. Okay, thank you. I can see that some of you are saying that most of these PDFs have been what? Released. They've been sent since last week. So I'm so surprised that some of you are saying that you are yet to get them. Both nitrogen 2 oxide and nitrogen 4 oxide can be formed by the decomposition of what? HNO2. I want you to take note of what we are talking about here. No direct reaction with oxygen. No direct reaction with oxygen. Now, take note of this next equation. Nitrogen 2 oxide can be formed through the reaction of copper with HNO3. Okay? That nitrogen 2 oxide can also be formed by the reaction between HNO2 and what? The iodide. While NO2 can be formed through the decomposition of lead nitrate, which gives us lead oxide NO2. What I'm emphasizing here is that nitrogen oxides are not formed by direct interaction with oxygen. If you take note of what is the upper part of page, what is this? Now we're on page 10. On page 10, look at the next equation. Different oxides of nitrogen can be obtained from the reaction, from a reaction that involves, by the reaction that involves the reduction of nitrates with acidic solutions, in acidic solution with metals such as copper. I want you to compare the reaction of copper with HNO3 here and the reaction of copper with HNO3 here. When you have different concentration of acids, when you have different concentration of the nitric acid, you will see that the products will be different. When you react copper with HNO3 in the diluted state, you are going to get nitrogen monoxide. nitrogen 2 oxide. But if the acid is in a higher concentration, that is a strong acid, when the concentration is greater than 1 molar, you are going to get what? Nitrogen 4 oxide. These are some of the things that you will be asked, because most of you will just look at it. Most of you will just look at it and you think that they are similar. No, they are not similar. The conditions are different. Higher oxides can be prepared by the dehydration of HNO3 with P2O5. We're talking of nitrogen in what oxidation state? In the +5 oxidation state. Take note of the other highlighted in here, that fewer oxides are formed by the other members of the group as compared to nitrogen due to their inability to form what? Double bonds. Apart from nitrogen, all the other members of this group do not have the ability to exhibit p-pi bonds. The p-pi bonds are actually the ones responsible for the formation of compounds in double bond, of compounds that contain double bonds. Compounds that contain double bonds. This is not exhibited by the other members of the group. It is only exhibited by the first member of the group. And this first member of the group is nitrogen. You can see that this was what we experienced with carbon as well. It is a positive anomalous behavior of the first member of this group. I want you to take note of another thing. That is the fact that the first member of group 3, which is boron, did not exhibit this. Is another area to ask questions. Why is it that the first member of group 4 and group 5 were able to exhibit the p-pi, and this led to their ability to form compounds with multiple bonds and the ability to form multiple oxides as compared to the first member, excuse me, the first member of group 3, which is boron. I want you to think about that. It could be one of your examination questions. The answer has already been given here. But one thing I want you to note is that as you move from the left-hand side of the periodic table to the right-hand side of the periodic table, it has been established that size does what? Size decreases. Okay. Oxides of phosphorus, arsenic, and bismuth and their oxidation states are presented in this table. They are presented in this table. Phosphorus, arsenic, and antimony. Phosphorus, arsenic, and antimony. Then bismuth. You don't forget that I told you that when you are dealing with bismuth, we are always cautious because of this extremely large size. But why is bismuth also included? Bismuth has to be included because it is the most metallic member of that group. And when you compare its stability to the unstable radioactive species, which is usually the last member of the group that is not occurring naturally, we are able to study these compounds, these elements and their compounds because they exist naturally. How? In their ores. But when you look at the what do you call it? When you look at the last member of the group, it is not stable at all because it is only synthesized. It is only synthesized, it doesn't occur naturally. And that element is what? Moscovium, which is related to where it was discovered. And where was it discovered? It was discovered in Moscow. That is why it is called Moscovium. Okay, let me go back to what I was saying. Here, there was a polarizing power. Okay, I'm sorry, the oxides. We're talking about the oxides of the other members of the group: phosphorus, arsenic, antimony, and what? And bismuth. Phosphorus will form compounds in the plus oxides in the +3 oxidation state and in the +5 oxidation state, as presented in the table. Please feel free to ask questions. Okay, but you can, if that class is organized, be rest assured that most of your questions will be answered. And what I'm even going to teach in that class is very simple. I will just teach the general principle. It is this general principle you carry into your study room. When you are studying, you'll be applying these general principles and you'll be getting a better understanding, just like I did in our first class. You can see them arsenic, the kind of compound that is from the plus 3 state in the plus 5 state by antimony and by what? Bismuth. What can you say about bismuth? What can you say about the oxide of bismuth? You will see that it still follows the same principle, that as we go down the group, the ability to form compounds in the lower oxidation state increases. It is only bismuth that is conforming its oxide only in the plus 3 oxidation state, which is the lower oxidation state for members of the group. Due to the dimeric nature of the phosphorus trioxide and, and the pentoxide, they can be presented as P4O6 and P4O10 respectively. While the other oxides on the table are what? Are dimeric. Both what? Both only Bi2O3 is not. Don't worry, it's just associated with its large size. Now, take note of the next highlighted 4 lines. Due to the high reactivity of yellow phosphorus when compared to nitrogen, phosphorus oxide can be obtained by what? Burning phosphorus in air. I want you to take note of that. I can ask a question by saying that which of the allotropes of phosphorus can be prepared by burning phosphorus in air? It is not all the phosphorus species that can be formed like this. It is only the one with the higher reactivity. And of all these that we have spoken about earlier, it is the yellow phosphorus that can exhibit this kind of action. Oxides of arsenic, antimony, and bismuth are also produced by what? Direct reaction with air and oxygen. Why is this so? Activity increases down the group as size increases. The ability to lose electrons also does increases. And that is why the reactions will be more spontaneous when you go down the group. You can see that it is stated here that this affirms the trend of increase in what? Reactivity as we go down the group. Basicity of the oxide also increases down the group. Don't forget that. Metallic character increases down the group. Also, basicity increases down the group. That is the reason why the bismuth oxide, the bismuth trioxide will be totally basic. As we are going down the group, we are moving from an acidic oxide to a basic oxide. Don't forget, as the metallic nature increases, the tendency to form basic oxide also increases. So when you are moving from nitrogen to bismuth, their oxide would transcend from their nature would change. We're talking about from the acidic state to the amphoteric state, and then to what? To the extremely basic state because of the increase in the metallic properties. Okay. Phosphorus exists in the plus 5 oxidation state in the phosphoric series, orthophosphoric acid, which is H3PO4, while it exists in the plus 3 oxidation state in the phosphorus acid series, that is orthophosphoric acid. I want to take note of this. I want to, by donating this, the lone pair of ability to expand this object. Since the stability of the higher oxidation state decreases down the group, and also due to the inert pair effect, bismuth does not form pentoxide. You know, we've been saying this over and over. Stability of the low oxidation state, that is what increases down the group. Stability of the higher oxidation state decreases down the group. This is the reason why bismuth will only form compounds in the plus 3 oxidation state. Of everything that we have now said, how does these things apply to our lives. I've told you at the beginning of this lecture series, I mean for group 5 or group 15 elements, I've told you that they are very, very unique because they affect our lives. How do they affect our lives? Because two elements in this group are responsible for the production of fertilizers. They are responsible for the production of fertilizers. Okay. And we're talking about what? We're talking about phosphorus and nitrogen. The other element is what? Potassium. And I've already stated to you that apart from the nature, the nutrient supply nature of potassium, it is there. It is also an agent that enhances the transportation. It is an agent that enhances the transportation. Okay. Um, Let me give you the second code for today. I was carried away. The second attendance code for today is 88KLD. 88KLD. That is the second attendance code. I'm so sorry it's coming this late. I'm supposed to be giving you the third attendance code in the next few minutes. Fertilizers and nitrogen fixing. Fertilizers and nitrogen fixing. Why must we fix nitrogen? Why must we fix nitrogen? We can fix nitrogen because nitrogen does not react directly in nature. If it reacts directly in nature, it will lead to nitrogen poisoning because it is existing excessively in nature, the most naturally occurring element. That is the reason why it has to be fixed because it is going to be used in the combined form. Now, let's look at what fertilizers look like. We said they are chemical substances used in enhancing the growth of plant to maturation and eventual production of their fruits in the healthy state. Now, plant fertilizers became essential because most soil lacked the necessary what? Nutrients. We must enhance this soil. You know, when you start producing plants, fruits, food items from a particular piece of land, there is no way where the nutrients in the soil will not be depleted because it is the plants that are making use of these nutrients. In order to enhance this process, there's the need to introduce more nutrients, and the species that is always added are the fertilizers. The most common fertilizers are the NPK fertilizers. They are the best and they are still in use. We have the naturally occurring fertilizers where you use cow dung, animal feces, and so on, but they are not effective. These synthesized ones are very, very effective because they are made to serve that purpose. Their components, their component is made in a specific manner to enhance the growth and the production of food items. Okay. Now, some of them even act as protectors of this species. Let's quickly look at some of these entities. We said of all these, nitrogen and phosphorus are group 5A or group 15 elements. And one of the important things about them is that they can initiate reactions themselves. That is because of the presence of their lone pairs of electrons. The roles played by this species, nitrogen, in the combined form, you will see that it is clearly stated there that it is in the combined form. It is the commonly used combined form is ammonium sulfate, and it is essential for leaf growth. It is essential for leaf growth. Do you understand this? Why is the leaf growth essential? Why is the leaf growth important? Without the leaves, there will be no photosynthesis. Without the leaves, there will be no photosynthesis. That is why the leaves, the existence of the leaves must be persistent. It must be encouraged. Without that, the plant will die. And if the plant dies, there will be no production of glucose, which is the main source of the energy. Phosphorus. It is in the soluble form of a superphosphate as given in the formula there, and it is essential for the growth of the roots. Um, Silent minerates also. Um, these notes are out already. They are out already. I was told that um, one boy is in charge of this. I'm surprised that this is even coming up at all. I can read that you will share it immediately. No, 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 no. It has been shared. It has been shared for my groups 3, 4, and 5. It has been shared. Okay. There's someone in someone has it in microbiology, but you have a general chemistry class rep. It was given to the general chemistry class rep, and he told me that it has been shared. But if you still have problems with getting it, you can reach out to me. I will give you everything afresh. But I'll be disappointed if some of you are saying, I'm surprised that some of you don't have this note already. So what is the essence of doing this? It has been given out totally. And I'm not talking about this week. It was circulated last week. It was circulated last week. Okay. Okay. Um, Definitely, phosphorus is very, very important in this because phosphorus helps in the development of the roots. If the roots are not there, there will be there will be a big problem of the existence of the plant because it is the root that taps this nutrient from the soil. It taps this nutrient from the soil and it supplies it to the other parts. It is the core. It is the core species that gets the nutrients from the soil and then passes it on to the plant. Potassium is essential for flowering. Potassium is essential for what? Flowering. Why is it important? Without the flowering, there will be no pollination and there will be no need for plants product for the fruit production. The fruits cannot come if the plants are not if the flowers are not pollinated. You can never see any fruit coming up without the flowers. So the potential enhances the plant the flowering process, and it exists in the form of what? Potassium sulfate. We said here that nitrogen cannot utilize a large amount of nitrogen. Plants cannot utilize a large. Okay, thank you. Thank you, Israel. You said the notes are out and you have them already. Thank you for the information. Okay, plants cannot utilize the excessive amount of nitrogen that are existing. Therefore, and if nitrogen exists in the atomic form, definitely all plants will die. And that is why they are always made a little bit unreactive, but they are easily absorbed into the roots in the combined state. This combined state is usually in the form of nitrates, ammonium salts, and then urea. It must not be in the free, it must not be in the free state. Okay, we now also have nitrogen fixing species in the form of bacteria. When these nitrogens are in the combined state, the nitrogen fixing bacteria, which is the Clostridium pastorianum, which exists in the roots, they will now reconvert it into the essential nitrogen that is needed for the plant. This is very common in leguminous plants. This is the reason why when people are combining mixed cropping, they are combining this mixed cropping because they want to fertilize the ground. They want the nitrogen to be introduced. So they will plant a lot and other species. When they plant leguminous plants, they will still plant other species because they also want good what? Good and numerous fruits. Their products will be increased if the flowering is what? If the flowering is in excess, each flower will produce the essential fruits that is needed. So that is why the Clostridium pastorianum is very, very important. Why is it very important? Because it enhances the what? It also enhances the production of what? Of which produces the essential things. Okay, let me quickly go through the nitrogen fixing process. It is just the herbal process. You've done this in your secondary school. Cyanamide under a high temperature and pressure. A large amount of calcium cyanamide is usually involved when nitrogen fertilizer 1 to 3 between nitrogen and hydrogen. Calcium cyanamide produces the calcium, your calcium cyanamide. This calcium cyanamide will now combine with water to give you the calcium carbonate and the ammonia. Nitrogen becomes reactive in this combined form. It becomes very reactive in this combined form. Okay, you cannot use nitrogen directly. Take note of that. Nitrogen cannot be used directly. If it is used directly, it will be in excess and it will lead to what? Nitrogen poisoning. And once that comes up, the plant will die. Now, the phosphate formation. The phosphate formation is given in the latter part of page 12. But before I continue today, I hope you all have it. Phosphate. Oh, I'm sorry. Maybe it's the audio thing. Okay, I will raise my voice. I'll raise my voice. Okay. We are not hearing properly. Okay, let's look at the phosphate formation. The phosphate formation, this involves a chemical process where we produce soluble phosphate and superphosphate. It is important for the phosphate used in fertilizer production to be soluble. If it is not soluble, they will not migrate to the essential sites. If they are not soluble, they will not migrate to the what? Essential site. And the kind of soluble phosphate we produce are in the form of superphosphates and what? Or triple superphosphates. When calcium phosphate is treated with concentrated H2SO4 and H3PO4, respectively, you can form the superphosphate and the triple superphosphate. What characterizes these two species is that they are soluble. Their solubility leads to their migration to the essential site. If they are not soluble, they are just going to be concentrated in a particular area. Solubility is the essential thing for the production of the phosphate. The phosphate produced, for it to be active, it must be what? It must be very soluble. The equations for the production of the superphosphate and the triple superphosphate are given in that on the latter part of page 12. A combination of an already fixed nitrogen in a combined state with a slightly soluble superphosphate or triple superphosphate and potassium would form what? What makes what? A very good NPK fertilizer. What are the essentials? What are the essentials? You might think that some of these things that we have not highlighted are not important. No, they are extremely important. Why are they extremely important? A question can be asked: in what form can nitrogen be effective in what? In fertilizers? It has to be in the combined form. Why? Because if it is not in the combined form, it leads to nitrogen poisoning, which usually kills the plant. In what form is the phosphate needed in fertilizers? It must be in the superphosphate or what? Superphosphate, or in the triple superphosphate form, which must be what? Soluble. If they are not soluble, they will not be able to migrate. All this will now combine with what? potassium in the sulfate form. Potassium in the what? In the sulfate form. And this is going to give us a super NPK fertilizer. Application of group 5A elements, which are group 15 elements. Here today, there is really no problem. The slides are, I didn't give slides, I gave PDF. Take note of that. They are in circulation. And if by chance you cannot get them, you can reach out to me through anybody. It's very easy. My office is room 210, chemistry department. I can give you, and maybe you help circulate it better. But from what your classmates are saying here, they said it has been properly circulated. Okay? Go to your class rep and ask for it. Thank you. Applications of group 15 elements. Nitrogen is useful in the production of what? Of explosive in warfare. Organophosphorus are very good in the production of insecticides. Organophosphorus are also used in the production of insecticide, and they are also used in warfare. Arsenic is used in agriculture to produce to control pests. Arsenic, if you ingest arsenic, a little quantity of arsenic, it can be lethal. It can easily kill. Most of the poisons that they make now are actually that they produce are actually lethal. They are not produced to kill. They are produced for certain purposes. For instance, some of them are in agrochemicals to help kill what? To help kill the pest. But people are using them in another manner. Arsenic is not something that you can joke with. It is a little quantity, can be very, very toxic. Antimony and bismuth are used in as components of what? Alloys. Nitrous oxide, which is known as laughing gas, is an anesthetics and is also used in as a what? Recreational hallucinogen. When you're supposed to be subjected to a kind of pain for medical purposes, nitrogen oxide will make you forget that pain because it takes you to another level. But do you also understand that anesthetics also kills? Anesthetics also kills. So they must be used in moderate amount. Okay? It is also used in motorsports because of the ease associated with the release of oxygen for combustion. Nitrous oxide is also used in motorsports. You know that those motorsports move faster. And this is as a result of the what? Complete combustion of their fuel. The nitrous oxide also helps in ensuring that more oxygen is produced. And the rate at which oxygen is produced determines the rate at which the vehicles would move. It is said here that it delivers more, it delivers about 33% more oxygen into the fuel, which is higher than the 21% released from the atmosphere. You know that oxidation process, oxygen, is what helps in the combustion. So they will now add nitrous oxide into possibly their PMS or their fuel, and the more oxygen will now be produced. And the higher the oxygen, the higher the power the vehicle would exhibit. Nitrogen and phosphorus are essential for life. Phosphorus is used in the production of matches, fireworks, and fertilizers. And they are also used in the production of pesticides. It is important because phosphorus, the pesticides from phosphorus are the strongest. The pesticides for phosphorus are the strongest. We call them organophosphates. They are the most potent of all the species of insecticides or agrochemicals that you have. But the only problem they have is that they are short-lived. So they are used for different purposes. When you want to get rid of pests as quickly as possible, you use the organophosphate. And the major components here are the phosphorus. The toxicity of the arsenic has been made useful in the production of rodenticide. This is what arsenic does to both rodents and humans. If someone is subjected to arsenic poisoning, it leads to hemorrhage, internal bleeding. And this internal bleeding happens in the brain. This is the reason why you just see a rat. The rat is killed and you meet it at the spot where it is killed. That is because it has affected the brain. There is going to be internal bleeding, hemorrhage, and it affects the brain, and they die instantly. Okay, this is not arsenic is not a very good element that anybody should be expect to be exposed to. Arsenic is supposed to be handled with care. PCl3 is used in soaps, detergent, plastics, nylon, and so many other products. Okay. Antimony is used in the production of alloys, and arsenic and antimony are used in the production of semiconductors, such as gallium arsenate and gallium stibnate in electrical devices. Bismuth finds its uses in paints, cosmetics, and the production of some drugs and medication. It is also useful as what? As catalyst. I want to round up by saying that it is important to note that when you are talking about the usefulness of this species, they must be used in calculated amounts. They must be used in what? In calculated amounts. If they are used excessively, it leads to poisoning. This is where I'm going to end my classes with you, but I'm hoping that you'll be able to organize the physical class. We'll be able to see each other face to face. It is going to take place in 1000 seater. We can pick the time and I will actually give you a summary of everything that we have done here. I hope you must have done well in your test. I am wishing you well in your forthcoming exams, and I look forward to questions after you have studied. Do have a wonderful day. It's been nice talking to you all. Do have a nice day. Bye. Thank you very much, sir.
Thank you, sir.
It's your
Well,
honor.
sir.
At least,
You're done with the electrical.
yes, I am. But they are saying that they want a
Physical class, so they can give
I would oblige them really, because I told you that I don't like this. I don't at
yes.
all. I don't, because a lot of them are usually coming to the office, and if the kind of questions they're asking infuriates me. Ṣé kò yé yín ni? Kò sì ní yé wọn. Okay, how many of them came to class today? Are they up to 100?
Most of them are still be sleeping. Yes. Drop your number, so I get it from I've gotten the material.
At the initial stage, they were just 16.
Ah, some of them.
But a very few. Because I would have loved to give the what you call it, the coordinator.
The thing is, you can when you have the chance, you just take them so that they will come with general question.
Okay. I'm actually, I say no, sir.
All right, sir.
See you another time. Bye.
Oh, yeah.